Are you trying to record the session?
In theory, yes.
Okay.
With random, vaguely sketchy free
Oh,
app.
this is cool. Well, unfortunately, when I look at myself there, I'm standing directly in the way of the
Right.
So, actually, no, maybe I should be over here. That's perfect. Yeah. Alright, well, now that I apparently have everybody's attention, I guess we'll get started. So, welcome everybody. Thanks for coming to the talk. Before getting started, they did this thing during the Servo talk that I thought would probably be useful. I just want to do a quick straw poll of what people's backgrounds are. So how many people here are sort of not of at all any sort of coding variety? Right, we've got Doug and we've got Blake. We're in good shape. All right, so I'm assuming everybody else writes some kind of code. How many people are primarily JavaScript developers?
Well, that kind?
No, not JavaScript engine developers. Your primary language of writing is JavaScript. All right, and then how many people primarily write C++? Okay, well that's a good mix. So I'm going to try and come at this, from as a general perspective as possible, not assume a ton of background information, but we can get into some pretty deep stuff. So anyway, my name is Bobby Holly. I'm better known as B Holly on IRC, and I've been around Mozilla for kind of a while, since 2008, and back when I used to own the color management module, which I've thankfully given up since then. And I've been to the last 2 summits and to Moz Camp and some other things. And this summit, when I looked at the schedule, it struck me as like a little bit different than the other ones, because it seemed to me like there wasn't really any place for first-class tech talks, right? Like something like what this is. And they were suggesting that we do open sessions instead. And I asked, said, well, it didn't really make sense, I think, with the format of what I was trying to do. So the long story short is this got turned into some sort of tech talk. And maybe that's, I understand that could be controversial or not necessarily fair to, other tech talks that were open sessions, 3 to a room. But that's sort of how it is. And I think that we should sort of use this as a basis for a conversation for future Mozilla events of what we're really looking for, right? Because I, for myself, was kind of looking for a little bit more technical content, but I also understand that technical content can be exclusive to some people. So let's just kind of take this and roll with it and see where we go. So anyway, I work primarily on this thing called XP Connect. And XP Connect is a little bit infamous. It's sort of the central nervous system of Gecko, right? It's where all these nasty pieces plug together deep down the boiler room. It's like 5 or 6 layers deep underneath everything else. So usually, I'm kind of down there, and I'm a little bit divorced from all of the consumers of my code, and I'm sort of working off in my own world. But sometimes when I stop working, I hear some noises trickle down from above. And often it's one of you guys being, sort of screaming in anger, like why doesn't this work, right? And so that's really what I'm hoping to alleviate in this talk, right? Everybody is always welcome to ping me, I'm B Holly on IRC. I kind of have funny hours sometimes, but I'll always try and answer your questions. But that doesn't necessarily scale. So what I would really like to do is to give everybody some conceptual insight into what happens in the JS engine, how it interacts with the DOM, how all this security stuff works. So that when you run into problems, you can ask yourself, okay, well now I understand these basic concepts of how the security architecture works, and hopefully solve your own problem. So I'm going to start with some basic overview and some history of how this stuff used to be, how we got into the state where we are today. And then I'm going to dive into some particular topics that I know people want to hear about, right? Like cross-compartment wrappers and X-ray wrappers and exposed props and brain transplants and all that stuff. And thankfully, we somehow have 2 whole hours in here. So I know that's a long time, especially for XP Connect. And I won't be offended if anybody gets up and walks out in the middle. But just know that we have plenty of time, and I'm going to be here, so we will absolutely have time to answer any question that anybody has. So, dark times. I think that if I was giving this talk 3 years ago, it would have been a very different talk. Largely because it would have probably been Blake giving it, who was the owner of XP Connect until I took over a little while ago. He's over there. He's trying to hide. No. But I think, more importantly, it would have been a different talk because it would have been much less satisfying, right? Like there would have been some discussion about, the types of security checks that are performed and the things that happen. But there would have been a little bit less of an overarching story of what security means in our engine. And the reason for this is that back then, I think the architecture was much more haphazard, especially with respect to things like security checks. And I obviously don't mean to trash on the people who worked on this stuff back then, because they were operating under some very difficult constraints. But in particular, with things like security checks, there are all these questions of like, when do you do a security check? And if you're doing a security check, what do you check? And how do you check it? And what do you do if the security infrastructure tells you it doesn't know, right? Like, do you allow the thing? Do you not allow the thing? And it was pretty janky and inconsistent, all told. And a lot of this really resulted in the fact that the web wasn't really ever written to a spec, right? Like, there's still not a spec. There is HTML5, which is an ongoing effort to kind of standardize our behaviors in ways that are web compatible. But in the early days, right, like, web browsers were written as a glorified document viewer. There wasn't, it was like, oh cool, we've got some hypertext, and then Brendan had this idea that he would put in a scripting engine, and then we got JavaScript. But it wasn't really until people started, innovating with the web and saying like, hey, I can make a bank website, and hey, I can make like a gambling website, and an adult entertainment website, and all these different things. And people started using them all in the same user agent. And then you sort of had the situation where there was very sensitive content coming from sources with very, very different trust characteristics that were all being rendered in the same engine. And then, of course, security researchers came along and were like, hey, like, look what I can do. And the response for the browser vendors was, well, let's not allow that, right? And then somebody else did something else, and, well, let's put a security check there, and monkey patch that, and, these things kind of spiraled. And basically, there wasn't really any overarching process by which this stuff was designed. It was really spread around. And there definitely were some pieces of security infrastructure, like there was CAPS. There was the script security manager, but it was difficult in its own way, and it didn't really encompass everything in the way that I think the modern security infrastructure does. And because it was scattered throughout the code, it really lacked clear rules and invariants, which are exactly the sort of thing that you need when you're reasoning about security. You need to know what is allowed and what is possible, and what is not allowed and what's not possible. And because these things weren't there wasn't really as much discipline to maintain good security hygiene. And we basically had a lot of security bugs. This all changed, or began to change, with the lead up to Firefox 4, which is something called Compartments. And compartments are really cool, obviously. You've probably heard of them because they were the title of this talk. But they were not really immediately motivated by security. And they were motivated by something else, which is sort of, garbage collection. In order to understand a little bit about that, you have to understand how the JavaScript heap works. And so I know some people already have some sense of how this works, but I'm just going to give a little bit of an overview so that everybody's on the same page. So in JavaScript, the fundamental thing, the fundamental unit of exchange is an object, right? Script comes from the internet, it gets turned into like something that runs by the JavaScript engine, and it starts creating objects. These objects obviously consume places in memory, and every object in JavaScript is associated with a given global object, right? This is what you get when you do a bare word property lookup in script, right? This is sort of where all the references end up leading. And all of the JavaScript objects have these kind of parent pointers that will eventually lead you to a global. But originally there were, you'd only ever be running like 1 or 2 web pages at a time. And so we had one single JavaScript runtime, and we just, these objects had to live somewhere in memory, so we would just put them in one single JavaScript heap. And this heap was a little bit, kind of like spaghetti, and it sort of looked like this. Because all of the objects were just sort of allocated here and there, and the heap allocator put them wherever it wanted to. And this was very difficult for garbage collection. I think a good analogy of this is if you imagine people living in a house together, right? If the rule that everybody comes up with is that you just kind of dump your stuff in the living room in various piles, then maybe that works if you have like 2 or 3 people living in the house. But as you start to have more and more people living in the house, it doesn't scale. Because, if there's one person who's like a total hoarder, or one person who's always getting new stuff and getting rid of old stuff, then everybody really suffers because there's all this clutter. And every time you want to clean anything up, you kind of have to get everybody in there so that, because the stuff might belong to anybody. And this is basically exactly what the problem we had with garbage collection was. Because as people started to use tabs and use more and more tabs, you went from having 2 or 3 tabs to sometimes like quite a few hundred. And so you can imagine that if you have your Gmail tab open, and your Facebook tab, and your Twitter tab, and 197 other tabs, imagine that most of them are idle, but you're looking at your Twitter tab, and your Twitter feed is just totally rolling, right? Like there's this bump in Twitter discussion that's going, and the tweets are just coming in. And the script that's running that Twitter feed is going to have these messages in its queue for a while, but sometimes they sort of float off the bottom of the screen. And then when the JavaScript is kind of done with them, it just lets go of them. And this is fine, because this is the contract of JavaScript, right? It's a garbage collected language, and you can just throw away objects, lose your references to them, and then the JavaScript garbage collector will come along and clean it up. Unfortunately, when you start having more and more and more web pages all using the same heap, this starts to be really expensive, right? Because every time that Twitter generates a bunch of junk, the JavaScript garbage collector has to wake up, but it has to trace over the memory of all 200 tabs. And this has to do it every single time that Twitter generates garbage, even if none of the other tabs are generating garbage. So this was obviously inefficient and bad for performance. So the idea, I'm not sure exactly who to credit it with, but I think it was some combination of Andreas and Jason Orendorff and some other people, was, well, hey, why don't we just put all of the memory related to the same tab or the same global in a separate heap in memory, right? So rather than just using one giant heap and allocating using the heap allocator these objects in this spaghetti fashion, let's just put them all in different places. And then, when we need to garbage collect one of them, we could just garbage collect it by itself without looking at all of the other idle tabs. So, compartmental GC, as this was called, ended up, it was cool. It was shipped in Firefox 4. But for a number of reasons that I'm not going to get into right now, it wasn't really as cool as we had hoped that it would be. However, it ended up having really incredible security implications. And they're security implications that I don't believe, we even really fully understood until quite a while after we'd shipped Firefox 4. And I want to really emphasize that this stuff, is cutting edge. It's known in operating systems research as object capabilities and membranes and this kind of stuff. And while it has existed in research for a long time, as far as I know, Gecko is by far the largest and most prominent and most interesting software project that is using this kind of technology. So I remember, many years ago, my operating systems professor made a quip during class that, object capability systems are the future, and they always will be, because they never find traction in practice. So in January, I sent him an email. I was like, hey, David, just so you know, we're doing this now. And he was so excited that he invited me to come give a talk to his research group. And then I did. And they were so impressed that one of them came to work for us. I don't know if you guys know.
Who?
Dayon?
Yeah.
Research intern? Yeah, so now he's writing his thesis about information flow control in Gecko. But the point is that this is really cool stuff that I think that we should be proud of. And I think it makes our engine, obviously, in terms of security, there are things that are less secure about our engine than WebKit, our lack of process sandboxing. But I think this is something that fundamentally, in this respect, makes us way more secure than them. So, there are some implications of compartments, which I want to get into. The first thing has to do with computing the origin of an object, right? So on the web, origins, which is sort of the domain that a web page or a script or an image comes from, these are really the basis for security checks. And the idea is that generally, if two origins match, if both things come from bank.com, then they're sort of allowed to talk to each other and interact. And if they come from different origins, like one of them is evil.com or even fupi.bank.com, then they're not allowed to interact. So in a lot of situations, we have these objects throughout Gecko, and we need to know who the object belongs to. And in the old world, this was sometimes a little bit tricky. And you can sort of think about it in the analogy of people living together in a house, that if everybody's got their crap in the living room, and you sort of wander in the living room, and you're like, well, who does this belong to? And you sort of have to ask around, and does anybody know? And maybe nobody knows, and it's kind of a problem. So what we did in the old world was we sort of had this oracle that was the NS script security manager, and you would sort of have to ask it, right? You would do a bow, and then you would put the object in the thing, and then you would put in a quarter, and you would crank it, and it would crank for a while, and then hopefully it would give you an answer. But it was really not necessarily an obvious process. But with compartments, we can do so much better. We can know this answer without even trying. Because whenever we create a compartment, we attach an origin to it, right? Because we're creating a compartment for some script that's coming from a web page. And we just, when we create the compartment, we attach the origin and say, this is the origin of this compartment. Then, whenever we want to know what the origin of an object is, we simply examine its memory address. There's no way that can lie. The object lives somewhere in memory, and all you do is look at the memory address, mod off some of the least significant bits, bam, that's the pointer to your compartment, and that tells you exactly the security characteristics of the objects. There's really not a great way to falsify that. So, the analogy of this is that, if everybody keeps their stuff in their room, then you don't really have to ever have this question of like, hey, who does this belong to? Because if you walk into somebody's room and you look at something, then obviously it probably belongs to them. So that already is really cool, because it means that given any JavaScript script object in the entire system, we know exactly which origin it corresponds to, which already eliminates a large class of security bugs. But it goes further. So we have this thing called entering a compartment, right? And this is so important that that in particular was the title of the talk. And this is really what's key to security hygiene. We have this fundamental invariant throughout the engine and throughout, through JavaScript and Gecko, that the engine is only allowed to interact with the objects of one compartment at a time. So what it has to do is doing what's called entering a compartment, which says that I'm going to start having this exclusive relationship, this sort of like temporary monogamy with this compartment. And I'm only going to interact with this compartment. And if I want to interact with things in another compartment, I have to first leave the compartment and then walk over and enter that compartment. So it's sort of a very serial process by which you explicitly declare which kinds of objects you're going to interact with. And this is heavily enforced in ways that I'm going to get to in a little bit. And so it's very safe and we can rely on it. And this is really key to us knowing that references do not leak between compartments. But it has a very cool side effect. So in addition to computing the origins of given objects in the system, another thing that we want to do is to compute what we would call the origin of the caller. And this is basically the basis of the security checks that you've most likely run into, right? Like, do I have the privileges? So whenever JavaScript is doing something, right, let's say it wants to open up an XML HTTP request to bank.com, whether or not that's okay totally depends on whether the script that is running it is bank.com or some sort of privileged script, or whether it's some other unrelated thing like evil.com that's trying to do an XSS. And so, previously, this question of trying to figure out, like, what are our privileges or who is responsible for this code was a major difficult task. And it was something that, in particular, this security researcher named MozBugRA4 was constantly getting us on, right? Like, we would think that we got it, and then he or she would say, here's another one, here's another one. And it was this constant game of whack-a-mole. However, in the compartments world, we can do so much better. Because in JavaScript, functions are objects, which means that just like any other object, the function lives in a compartment. And we also store just regular JavaScript scripts in compartments as well. And because we have this invariant that says, anytime I want to interact with an object, and that includes calling it, I have to enter the compartment, then we know that if we're executing any piece of code that came from anywhere on the web, we must have entered its compartment. Otherwise, the browser would have blown up, right? Like, we have these very strict rules that we've got to enter a compartment. And so that means that it gives us an incredible amount of freedom and power, because we know that we've definitely entered its compartment if we've executed its script. Even if the JavaScript engine is no longer running in the JavaScript world itself, but it's called out to other parts of the engine. And this is awesome, because it means that we don't have any more of these kind of Chrome privilege leaks that basically every add-on author was always worried about but never really fully understood, like, how it might happen, right? There was always this feeling that, well, like, if I call into content code, then maybe I'm going to leak my privileges to that content code somehow, right? But that just doesn't happen anymore, because you know that if you've called into content code, you've entered the compartment of that content code, and therefore we can use, the current compartment of the engine to tell us exactly who is most recently responsible for what's going on. Basically, your security privileges are those of the compartment. So anyway, these are just kind of like a couple of the ways, architecturally, that this design answers so simply and so definitively a lot of the questions that are very fundamental to security and that were problematic for us before. Because, if you want to know the privileges of something, be it yourself, like the caller, or an object, you simply examine the privileges of the compartment, and you know the answer. So anyway, from there I'm going to go and dive into a little bit more of the specific topics that I think are perhaps more of interest to everybody. But before that, now that we've sort of given the general architecture, I want to ask if anybody has any questions or parts of that didn't make sense.
Did you address the governmental domain?
Have not addressed that yet, but that will be addressed in the last slide.
Oh, okay.
That involves brain transplants, so we're gonna, yo.
So I'm just trying to get clear on what the security invariant here is supposed to be, which is that is it invariant intended to be, if you're in origin A, no access to any object, which is in a compartment of origin B?
Not unless you enter the compartment of origin B.
okay, but from the perspective of writing I mean, I've got JavaScript code executing in origin A.
Mm-hmm.
Let's say talk about content entirely, right?
Right.
Is there any way to access objects which live in origin B?
So you are not allowed to access them directly. What you will do is you will access them through cross-compartment wrappers, which I'm going to get to like in the next slide. So
okay,
but the idea is that you can never touch them directly. You're always going to have some sort of wall in between, and the security characteristics of that wall are something that we can compute very effectively.
Can you describe in a little more depth how you use the memory address to define compartments?
Yeah, sure. So the basic idea, right, is that these compartments live somewhere in the heap, and these compartments have what we call arenas, right? And every arena knows which compartment it's associated with. So compartments, you can effectively think of them as heaps. There's like a couple layers of pointer indirection. But if you have a given JS object, then all you do is you mod off the least significant bits of that, and that will give you the arena. And once you have the arena, you can just cast that pointer to an arena, and then that arena knows which compartment it's associated with. Jeff, is that still right? Or?
That sounds plausible and right enough to me.
Like,
not quite true anymore with zones.
Right, that's right.
So now there's more kind of chasing where you find the compartment.
Right, but you still use the address to find your arena, right? No?
You can, so that only gives you the zone. So you can't get to the compartment.
Oh, okay. Got it.
So you have to go through like the last compartment.
But I thought we only use zones to store strings across compartments. Okay, I'm wrong.
Briefly notice the difference between a zone, an arena, and a compartment, just for my rather dry brain.
So an arena is, arena is the actual heap region where the objects are allocated. The compartment is the conceptual unit that we use, to say that, there's one compartment for a given global object, and that's the layer of security encapsulation that we have. A zone is an optimization that we came up with after in the V2G days, right? When compartments were causing us to use a lot of memory because we sort of had to have these like copyings of things and wrappers for things, and there was a little bit more overhead associated with this encapsulation. And so we had this idea that we would kind of, a little wink and a nod, let's shove a couple compartments into kind of the same region in memory, especially ones that didn't really need to be isolated from each other from much of a security perspective, and ones that very often had similar garbage collection characteristics, right? Which meant that they should probably be GC'd at the same time. So in the modern world, the zone is a little bit of an implementation detail. You can think of it mostly as like what objects do what things do you want to be garbage collected together, whereas the compartment is the security unit of security abstraction.
Yeah.
Anything else? All right. So, obviously, what I said before was a little bit too simple. So, it is true that the thing about compartments, the thing that makes compartments so darn useful and special, is that they have this fundamental property that we never allow direct references from objects in one compartment to objects in another compartment. And this is fundamental from whichever perspective you come from, right? If you're coming from the perspective of the garbage collector, you need to know, in order to be able to say that I'm just going to collect this Twitter tab, you need to know that there's not necessarily some other reference coming from your 197th tab that's holding alive this object that you want to free. Because if that were true, then you would have to look at the memory graph of all of the tabs, in which case you're back to square one where we were before compartments. And if you're coming at this from the security perspective, you need to have very strong invariance saying that you know that there's not going to be any sort of leaks between these compartments where we want to draw security pointers. But unfortunately, the web does not make life super simple for us. Because, obviously, as I'm sure you all know, you can interact with things from other globals. And these globals can be same origin or they can be cross origin. But now that we have one compartment for any given global object, these references definitely would adhere to cross compartments, right? So the most simple example you can come up with is that you have a web page. The web page has an iframe, and you document.getElement by ID of the iframe, and then you access its .content window property. And the .content window property is the window property of the iframe, which is a distinct JavaScript global from your own window property, which is the window for your script. So now you're touching the global object from another compartment in what appears to be a very direct fashion. So obviously, that seems to violate everything I just said, so it gives. And the answer that we came up with, or that people before me came up with, was that we're not going to give you a direct reference to the window object itself. What you're going to get instead is a sort of proxy object that represents, in all capacities, this object that you want to touch, but it isn't that object. And in particular, it's an object that lives in your compartment. So this allows us to maintain that invariant that all of the object references that we have, that the script is dealing with, live in the same compartment. Because they're, if they want to touch something in another compartment, they're actually just touching this proxy object. And this proxy object is something that we call a cross-compartment wrapper. And cross-compartment wrappers are special because they are the only objects in the system, more or less, that are allowed to access things from other compartments. They are allowed to traverse this compartment boundary. And the reason we allow this is because we have very, very, very carefully written them, such that they maintain a layer of wrappers whenever they bring an object back and forth across the boundary. So, it's a sort of transitive membrane thing, and you can kind of think of it, in a way, as like a wall of latex between, compartment A and compartment B, right? Like I can, if I'm standing in one compartment, I can kind of reach through the latex because it's, it's very squishy, and I can grab some other object and I can try and bring it back across. But really I'm not holding onto the object directly, right? Because between my hand and this object is this membrane layer. And the membrane layer is exactly what we're talking about when, we're dealing with these cross-compartment wrappers. Because what they do is they make sure that every time, for example, you look up a property on an object via a cross-compartment wrapper, there's a value that comes back. But the cross-compartment wrapper is sitting in between and says, haha, I'm not going to give you that object directly, I'm going to put that object in its own wrapper and hand you back that. And similarly, if you're trying to define a property on an object on the other side of the membrane, then before putting the value over there, the wrapper says, no, I'm going to first wrap the value you handed me in an appropriate cross-compartment wrapper for the other side, and place the property there only after it's been wrapped. And so this gives us what is known in the security and secure operating systems world as membrane semantics, right? And this layer is transitively maintained and gives us this very, very powerful wall, because things are never touching each other directly. They're always going through this membrane. And of course, a membrane is not going to be any good if even there's just one little hole in it, right? Because as soon as there's one little hole, then things start leaking through, and any sort of sanitation that you had goes out the window. And so we have invested an immense amount of engineering effort in the JavaScript engine to make sure that we always, always, always get this right. And this is done largely through these things that we call compartment mismatch assertions. So scattered throughout the JavaScript engine, there are hundreds of these. There are these assertions that just willy-nilly say, okay, any of these objects I'm dealing with here, this one, this one, this one, and this one, are they all the same compartment? If so, carry on. If no, crash the browser. And these are always enabled in debug builds, and we actually sometimes enable them on the nightly channel in optimized builds to make sure that we can catch things that extensions are doing. So in the early days of compartments, there were obviously a lot of compartment mismatches. But since then, there really aren't too many anymore. And in particular, as a JavaScript developer, you should never, ever be able to trigger a compartment mismatch. If you can, that's a very serious set critical bug. CC me. But aside from that, you can know that the fact that you can't trigger this compartment mismatch means that XPConnect is doing its job, and it's maintaining the kind of security membrane it needs around your script code in order to enforce a security policy. So the obvious question there is, what exactly is this policy? What kind of magical things do these wrappers do? And the answer is they do quite a lot of things. But first, the most interesting example, in a way, is the simplest kind of wrapper. And this is the transparent, vanilla, cross-compartment wrapper that you get when there's no security to enforce, right? Like, let's say you just load a same origin page in an iframe, and you start going through and manipulating that DOM. The cool thing about this is that there is a cross-compartment wrapper there, but you can't tell. It's totally invisible to script, because every operation that you perform on that wrapper gets forwarded to the underlying object, and then everything comes back and is wrapped in an equally transparent wrapper. And because you can never get a handle on the object on the other side of the boundary, because every time you try to, you'll just end up with the wrapper again, you can never do an identity check to say and realize that you actually don't have the object at all, because you can't get a hold of the other object. And so because this stuff is invisible to script, it means that we can expose it to the web, which is exactly what we do. There's obviously nothing in HTML5 that says anything about compartments or wrappers or object capabilities. But the point is that script can't tell whether it's running in an engine like WebKit or Blink, that allows direct cross-global references, or one like Gecko that doesn't, that has this extra layer of security in between, which is cool. Yeah?
You can, right?
I don't think so.
There's nothing in that.
Well, we'll get to document that in
I sense there are somewhere in there.
Can you briefly say what WebKit does?
Oh, so what WebKit does instead is that they just give you direct references to objects from the other globals. And what they rely on is, in terms of cross-origin security checks, is they just do explicit security checks on the only objects that they think that you'll ever be able to get to access, right? Which are basically the window object, the document object, the location object, and possibly another one for them, I don't remember.
I'm sorry. I'm just looking through Barth's paper from 2010 where he talks about his design for this, right? Do they don't do that where they have explicit access control checks on every reference for the target versus source origin?
So they only have explicit access control reference on the objects that they believe are reachable cross origin. So they basically say that, like, if all of our security checks work, then only these 3 objects are ever visible cross origin, and these are the only objects that need to do security checks. And for them, given that their embedding is done in C++, they have a better way of ensuring that than we do, because we have extensions, right, and God knows what extensions do.
Right.
So we kind of have to handle all of the cases to be secure, but it means that whenever they get a security bug, it's much worse for them than it is for us. And I have personally profited from this. In the bug bounty sense, not in the bug market. So anyway, so we can do these kind of cool wrappers that are totally transparent to script. But we can also apply a very customized security policy to do what we want, and do it in a very flexible and performant way. And the performance thing is really worth emphasizing, right? Because for us, the common case really functions at light speed. Because the common case in JavaScript is that script is manipulating objects from its own global. And in that case, we're never touching any cross-compartment boundaries, and so things can just run without any security machinery getting in the way. And there's basically no way to be faster than that. When we do have to cross compartment or global boundaries, which is, the less common case, we're still quite fast. Because we only have to do the relevant security check once. Like when we're creating the wrapper for the thing, then we compare the origins and decide what kind of policy we want to enforce. And whatever policy we enforce is baked into the wrapper that we choose. But once we've chosen that wrapper is cached, and then any access across that boundary will just go through that wrapper, and that wrapper has a static policy of exactly what it wants to enforce. So, an interesting question, right, is that what kind of policy are we enforcing in this situation? And I know I've been kind of leading you along with this question for a little while, but I'm going to lead you on a little bit further, because I think in order to meaningfully understand the types of security wrappers that we use, we first have to talk a little bit about how the DOM is implemented. That's a pretty big thing, but not really how the DOM is implemented, just some very basic things. So I've talked before about how these JavaScript objects live in this special heap inside the JavaScript engine, right? Like that's where this compartment boundary is drawn. However, the C++ representation of the DOM lives elsewhere, right? And this is sort of the canonical representation of the document. When you load a web page, it comes into the HTML parser, and the HTML parser starts generating this tree of C++ objects, which we call the DOM, right? You've got your document, your body, your divs, etc., in this tree structure. And this is in a different C++ heap for a number of reasons. It has a different ownership model, it uses reference counting instead of garbage collection, and it's very intimately tied with layout. So I know you're probably thinking like, well, that doesn't make sense because from script I've definitely interacted with the DOM, right? Like I've touched document.body.firstChild and stuff seems to work. And this all works through the magic of what has historically been XPConnect, this thing we call reflection, right? And reflection is the historical bread and butter of XPConnect/source, which is the idea that we are going to create reflections of objects between languages. So if JavaScript wants to manipulate an object from C++, we sort of create this doppelganger object in JavaScript that represents that object in C++. And in particular, we attach a bunch of useful getters and setters and methods to it that, when invoked, will operate on the underlying C++ object. So we basically have a representation of all of the useful operations you can do on that underlying C++ object, and we effectively expose that as an API, usually via the prototype chain, of these sort of reflector objects. So that means that when you manipulate those reflectors, the changes that you make go into the C++ DOM implementation, right? So if you do document.body.onClick equals some function, that function that you pass it will actually kind of be slurped down from the JavaScript land down into C++, and will be attached to the C++ body element itself. But I know that people also know that you can do other things that aren't necessarily defined in any sort of web IDL, right? You can do document.body.foopy equals 2, right? And these are what we have historically called expando objects, right? They are objects that, or expando properties, rather. They're properties that don't correspond to any sort of native web IDL thing, right? They're just random things that the developer decided to use. And because C++ is a very static language, there's no real way that we can shuffle that down into C++ and stick it anywhere. So what we do instead is that we leave the expando property on the reflector itself. But when we do that, we have to tie the lifetime of the reflector to the lifetime of the C++ object, so that anytime you're interacting with the DOM in the future, you always make sure that you see that property, so that this sort of illusion is preserved. And that is kind of bad for certain garbage collection heuristics, right? Because we sometimes want to lazily get rid of these reflectors and regenerate them when needed, but we can't do that if you've stuck an expando object on it. So that's generally, it would have been maybe nice if the web hadn't supported expandos, but that ship has kind of sailed, so we don't need to talk about it. So this is all well and good when script wants to access the DOM of its own document, of its own compartment, right? All we do is we create this reflector, and that reflector lives in the compartment of the script that's running, and then you just manipulate it. And a more interesting question then is what happens when script wants to manipulate the DOM of a different document, right? Of a document that was not the same document it was loaded with. And this is when we start dealing with these compartment boundaries, right? So imagine the obvious case if you load an iframe. And let's say that iframe is same origin, and you want to go in and start touching its content window. Because these things are same origin, we don't have any security policy that we need to do. So we can do the very obvious, simple thing, which is that we just create a cross-compartment wrapper from your compartment to the reflector in the other compartment. And so you go from your compartment to that compartment, and that goes down into C++. And this is totally transparent, and it's as if you had your own reflector. But we have various, deep architectural reasons why we can only have one reflector anywhere in JavaScript for a given C++ object. In particular, because for performance, we cache it on the underlying C++ object, and we can't have multiple ones. So anyway, in the same origin case, we just create a simple JavaScript cross-compartment wrapper to the reflector, and the reflector knows how to forward itself down. However, when there's different origins, then we need to apply security checks. And these security checks are mediated by the wrapper membrane, right? Because that's where we compute the interesting security policy that we need to apply. But one thing that not everybody realizes at first glance is that these protections that we apply need to be bidirectional, right? We need to both protect the caller and the callee from each other because of different security issues. And so this reason for this is not immediately obvious, so I'm going to sort of delve into both of these situations. The obvious example is that you want to protect the privacy and the integrity of something that is being inspected by script that it doesn't necessarily trust. So the obvious example, the thing that motivated most of web security is, okay, so let's say evil.com loads bank.com in an iframe, right? If it can just go and poke around the DOM, it can look at a lot of sensitive stuff, because probably your account number is somewhere in the DOM, and it just has to find the right child and look at text content, and then bam, it has your account number. So obviously we can't allow full access to that. So instead what you get is you get a cross-compartment wrapper that is very locked down and has a whitelist of properties that are allowed to be accessed on a whitelist of object types. So with these, we call them filtering wrappers. What they do is they'll just say, okay, you're trying to access this. What kind of object is it? And it will enumerate the same origin policy as has been defined, which, by the way, if you've noticed, has been getting a lot smaller recently, right? Because I've been working with Hixie and Abarth and all these people to try and shrink the same origin policy to the things that are actually common between all the UAs, and we've got it down to only exposing window and location cross origin. So there's just a couple properties on each that are available cross origin, and that's exactly what this filtering wrapper does, right? It says you're doing this property access. Is this a window object? If so, allow it only if it's one of these properties, writing and reading in these various configurations. If it's a location object, do something similar for location. Otherwise, deny access. It's a very simple thing, and it's very powerful because it means that we get security checks where we get security invariants for everything. Whereas, WebKit would just put the security checks directly in the implementations for window and location. We get proper security invariants even if some other object, unrelated in scope, happens to fall into the hands of somebody malicious, right? Because as soon as it goes across the boundary, we put this filtering wrapper in there that says, that's not something we expect to be visible across origin, so we're just not going to allow any access. The other kind of protection, though, is what we call X-ray vision. And this is probably something a lot of people have run into. And the basic idea here is that you're trying to prevent the caller from being confused by the data that it's accessing. And the most easiest and probably most familiar situation of this is when Chrome or privileged script wants to manipulate or poke around in a content DOM that it doesn't necessarily trust. So let's say you want to go do something, and so you do content window.document.body, and you start poking around at the structure of the document. However, let's say the content was malicious. It can do all sorts of crazy things to its DOM, and in particular, it can replace the body element on the document with some crazy getter that does something different. And maybe that getter returns a different document, or a different document's body, and causes the Chrome to start manipulating and inspecting a different body, and it doesn't even realize that it sort of has been misdirected. And this kind of thing, originally the answer was like, well, be smarter about it, right? But that's very, very hard, because in JavaScript, with all these sort of meta-programming capabilities that are built into it, with getters and setters and property descriptors, it's very, very difficult to avoid being confused in JavaScript. And we really wanted to make the common things safe, right? To avoid having extension developers be total wizards, and just make sure that we don't have these kinds of security bugs. So the obvious thing, right, is, well, let's just give you a clean view of the DOM without any of the crap that the content may have stuck on its reflector. And that's exactly what X-ray vision gives you. So you get this cross-compartment wrapper that is technically a wrapper to a target object, except it never really goes to that target object. It just goes directly to the underlying C++ object. It sort of has a direct line to the truth. And we know that we never end up getting confused by the target object because we never even enter the target compartment. And that's a surefire way, given our invariants, to know that we're not going to get confused and we're not going to run any getters and setters. And so this is basically very powerful. And it also has this interesting side effect that you get to maintain your origin as a caller, right? Because you're never entering the target compartment. And this ends up being powerful for privileged script that is trying to do things to a content DOM that the content DOM itself may not even be allowed to do. For example, let's say expose content, does a draw window into a canvas. And then in certain situations, if that draw window went over a cross-origin iframe, the canvas becomes tainted, and if you try and do a read pixels call on the canvas, it will fail with a security error. That read pixels call is implemented with a principal check or an origin check on the caller. So if you're accessing it as the content, you're not going to be able to see it. But if you're accessing it as the privilege script via an X-ray wrapper such that you never entered the target compartment and you never had an opportunity to be confused, and so you know that you're doing exactly what you expected to be doing, then the thing will succeed because it knows that there's no chance that you've been confused. And we know that the compartment we're in is that of the privilege caller. Yeah?
So these expandos in the target compartment are not visible. Sorry,
Right. So basically any monkeying that has happened at the reflector level in the target compartment is not visible with an X-ray wrapper. And we can guarantee that because we don't even enter that compartment, so therefore we can't even manipulate these things and look up the properties.
Have we decided yet what happens for a draw image when there is no caller?
Is no caller?
Like via set timeout or something crazy.
Oh. Well, so, right. There are situations when there is no script that happens to be running on a stack. And in that situation, that usually indicates that what we say is system is doing the indication, right? And in certain cases, like set timeout, we have to be very careful to make sure that we actually enter the compartment or whatever of the script that triggered this, so that we make sure that set timeout doesn't become a eval as Chrome or something like that. So so one of the problems with this method of computing the subject principle is anything that's asynchronous, anything that posts an event to the event loop, you have to be very careful to enter some sort of compartment and basically obtain some sort of security privileges, because the default will assume is that you're system principal if there's nothing else. But it's still much harder to be confused than it was before. Oh, yep.
What does happen if the caller, the caller sets an expando on
Aha! That's a very good question. So what we do is you get a totally separate view of the expandos from each origin you're accessing the thing from. And so we essentially, in the implementation, we have this map of, callers from this origin, get this expando object, and callers from this origin get, this set of expandos. And basically, it's sort of, in most cases, aside from like certain Jetpack things, this is basically just going to be, Chrome, the system principal, right, is going to have its own set of expandos that it sees on the location object, or on whatever the target object is, and that is totally distinct and totally disjoint from whatever set of expandos the target itself may have had, and whatever set of expandos anybody else accessing the thing over X-ray would have had. So X-rays are really great, and they're an awesome security protection. But there are certain situations where you may not necessarily want them, because maybe for some reason you do actually want to poke around and see what kind of properties that content has defined on the DOM. So if you don't want these X-ray protections, we provide a mechanism for you to give them up, for you to do what's called a temporary waiving of your X-ray rights. And this is really cool, because this is something that WebKit cannot do, right? They can, with their extension model, they can give you the sort of separate world, the kind of X-ray style view, or they can give you the world where you're just kind of running along in the content. But you can never really get both at the same time, given how they implement it. But given how we do this with X-rays, we can kind of provide both. So we sort of have these APIs of if you have an X-ray wrapper, you can get the wrap.js object property off of it. Or if you have something that you're not sure if it's an X-ray wrapper or not, so maybe it doesn't have this property, you can use components.utils.waveXrays or unwaveXrays to give you the waived version. And this waived version is a totally separate identity for the target object, right? So that basically means that some content object dot wrap.js object will not compare equal to some content object. Even though they both kind of refer to the same target object, one of them is an X-ray view and the other one is a waived view. And we consider those to be sufficiently distinct that we don't make the pointers compare equal. In particular, that means that you can use both of them at the same time. Yeah? I sure hope not. Sorry, what? Not since Firefox 4. It may be there's another usage of wrap.js object that means something totally different in XPCOM components. But okay, so yeah.
What used to be the equal would compare equal that changed to paragraph 4.
Ah, okay. So there you have it. And the implementation of these waivers is quite simple because it's more or less just another cross-compartment wrapper. You don't have to do anything fancy because all you do is you enter the target compartment and then you can interact with those things and you don't have to worry about anything unsafe happening because by virtue of entering the target compartment, you've already assumed all of its security characteristics, given how we compute the origin of the caller. So the only interesting thing that this wrapper does is it has this sort of transitive behavior, right? Whereas when every property that you pull off of a waiver will also have a waiver applied to it, right? So you don't have to call .wrap.js object for every other .lookup on your thing. You can just do it once, and then you sort of get this transitive series of waivers. And if you ever want to get rid of those waivers, you can just do components.utils.unwaveXrays. So I understand that obviously when you're writing JavaScript code, it can be simpler in some cases to just use wrap.js object and look at the stuff. But I would just wish to caution you that it's very easy to be confused, and so you want to think very hard about the situations when you're using that. In particular, if you're writing an add-on or something, security reviewers know that that's something to look for that is potentially a problem. So in particular, if you know and trust the origin of the content you're looking at, like let's say you're writing an extension that only operates on Bugzilla, then probably using wrap.js object is safe. But if you don't trust the content at all, it's really a pretty dicey game, right? And the way you should think about it is that you're interacting with malicious content, and that malicious content has the home field advantage, right? Because it can set up whatever world it wants and make that world as confusing as possible. And ever since we've given you these X-ray protections, there's sort of been less of a concern about trying to find ways to inspect for content to inspect its own world and avoid being confused. So, yeah.
So in Chrome code, I've seen hundreds probably of uses of wrap.js object. Do we know if those are right or wrong, or and I'm probably guilty to copy long strings of wrap.js object dot 1,000 other accessors and whatnot.
Yeah, I mean it really You should look at what it does, right? Because there are situations when it's safe, and there are situations when maybe it doesn't matter, like if you're just detecting whether a property exists and you're not doing anything security sensitive. But if you're ever trying to make a judgment about what a DOM actually looks like, then it's wrong, right? Because content can just, unless you're doing like lookup property at each step and like examining the property descriptor and determining whether it's a getter or not, which you're almost certainly not, you are likely to be able to be fooled.
Have you looked at any of these implementations? Or?
Maybe not of recent memory.
Do we have a list anywhere of places where it's probably wrong, that I can go through my code and figure out what I've done wrong?
The places where it's probably wrong are, you should look at it and you should wonder, if I don't trust this, do I trust this content? And am I doing anything potentially sensitive based on what I see? And if either of those things are true, then it's fine. Like if all you want to do is you just want to go and define some helpful like string on the window or something that content can see, and that it's not like a security problem if that thing doesn't end up where you expect, then that's probably fine. But if you're trying to make a judgment based on like what the DOM looks like, then it's probably not fine.
But in the example you're using, the getter and setter run in the security context of the content, not in your security context. Yeah. So it's not like they could just have a getter that maliciously grabs stuff from you.
Yes, but for example,
no, I'm not saying it's not bad. I'm just like trying to work out.
Yeah, it couldn't grab stuff from you, but maybe what it could do is it could point you to another document that it doesn't have the access to,
right? Yeah.
But that you might have.
Yes, confused deputy, right?
And then you could, then you would be poking around in that, and you'd be pulling out information that you didn't expect to be pulling out, and maybe that would end up getting exposed back to content.
But just to be clear, for the same reason, even if I somehow pass an object into something, that's still, the compartment still protects it the other way, right? So even if I pass in a pointer to my own object somehow,
to who?
To the content, right?
Right.
It can't directly access the object for the same reason you were saying before, right?
Yeah. Well, so the content accessing Chrome is a very different story, and this has to do with cows and exposed props, which we'll get to.
Oh, okay.
So we'll save that.
Okay, great.
The other side of what?
Like my previous question, what does happen if I set an expand of an subject, and especially if it's a function and the program gets to call this function?
Very good question. So, because you're entering the target compartment, if you set an expando on that target property, that thing will just appear in the content, right? Like it's just as if you were interacting sort of with a same origin thing and happening across globals. Like you have a same origin, content iframe, and you're going in there and defining some property, right? That's all it is. Now, if you define a function that especially happens to be implemented somewhere else, that will end up as a cross-compartment wrapper to a function that was defined wherever it was, and whatever security characteristics we compute there will be as they are. In particular, if it's a function, even if that function is defined in Chrome, the content will be allowed to call that function.
So I can add the privileged API to the function.
Yeah, but we really don't want you to do that.
I know. I was asking because I was sure you.
Yeah. It's a real big problem, and I'm going to get to that in a little bit when we talk about cows and exposed props.
So that the safe way to do this maybe is using the sandbox.
Yeah. So if you want to just set an expando, you can go in and do that.
For a content privileged function, a function which will have the low security.
Right. So we actually have built a mechanism that Gabor has been putting into Jetpack. So we've built sort of something specifically for this use case, and I'm gonna talk about that soon. So X-rays are great and all, but they do have some limitations. In particular, you can't create an X-ray wrapper to everything. And the main restriction is that in order to have an X-ray wrapper for something, there has to be this separate representation between like the C++ DOM and the JavaScript object. And in a way, this makes total sense, right? Because if you're trying to bypass the reflector and go to the underlying C++ object, you sort of need something underlying to go to. Because if it's just the JavaScript object, then it's just JS and there's nothing to X-ray to. But unfortunately, this is starting to seem a little more arbitrary and to hold a little less water as time goes on. In particular, you might ask, right, like, why can I have an X-ray wrapper to a DOM error, but not to an error, or a type error, right? That seems very arbitrary, and it happens to be because a DOM error has a C++ representation, and via WebIDL, an error and type error happen to be defined in ES5. And then there are more and more things, like, for example, typed arrays we end up implementing in the JavaScript engine, And Anna wants to move promises from being implemented in the DOM to being implemented in ECMAScript, which means that they're going to move into JavaScript engines and also not have any underlying C++ representation. So this is kind of getting to be more and more of a problem. And the long story short is that Jason Orendorf and I have a strategy, and we're working on it. We're basically kind of going to use the prototype chain of standard objects to create some sort of X-ray mimic that will hopefully solve these problems for us.
What do you do for JavaScript implemented DOM objects?
Oh, so those is totally fine, because whenever you're using the WebIDL machinery,
Yeah.
you have this layer of C++ between everything, and everything is just totally fine. So this is the thing that everybody really seems to want to get to, which are these things that we called, that Blake called cows. There's sort of this joke that, everything in XP Connect is a kind of ow, right? We have sows and zows and cows and kapows and many other things. Oh, this is not you?
This only one.
Who was this? Ben Newman. Okay.
I thought his were JPOO. JavaScript process wrappers.
Okay.
Yeah.
Anyway, moving on. So in the very old world, I think before we knew a lot about security, if content was ever able to get its hands on a Chrome, privileged JavaScript object, it was just kind of allowed to do whatever it wants. We didn't have any sort of security restrictions. And this was really bad, right? I'm sure you can imagine that you get one Chrome JavaScript object, and then maybe you get its proto, and you work your way up to object.prototype, and you start invoking object.prototype.define properties Chrome, and the world kind of goes to hell. So this didn't work. And so we kind of put in the security mechanism, and then at some point I made the security mechanism mandatory, which I think resulted in me getting a Mozilla meme made about myself, where I'm Ron Burgundy, and just saying fuck you to everything that I broke. But it was really important to do. So these kinds of, the security mechanism that we put in place was this thing called exposed props, or cows. And the basic idea was that, well, these are privileged objects, right? This is Chrome, it's sort of, it's an adult. It's allowed to decide, why don't we allow it to decide exactly what the access control is, right? We can allow it to define in JavaScript the precise list of properties that can be exposed. And this kind of makes really a lot of sense when you think about it at first. Because you can say, well, I want to expose this object to content. And maybe I only want to, give it, this property and this property, and I want read access to this, and read-write access to this, and etc. And that's exactly what exposed props was. Like, it was this object where you literally just defined a list of properties and the access control for each of them. And it would have been, of course, much nicer if we could have just said, no, like, you cannot touch Chrome JavaScript objects at all. But people had started to use Chrome JavaScript objects, sort of as you said, as a mechanism to expose APIs to content, right? So they would define a couple functions on an object, hand that object over to content, and then expect content to call this function. And so, with this legacy, it was sort of difficult. It was already difficult enough to implement this exposed props thing, and it really broke the world and was at the limit of what we could really push through. But unfortunately, these never really turned out the way we wanted. Because, first of all, it was like, okay, well, if it's an array, then you probably don't want to put like every array index in the list of exposed props, right? So, okay, so let's allow indexed access on arrays. And let's allow them on typed arrays. And then if it's an array, then maybe you want to call for each, or any of these other standard array.prototype operations. You don't want to have to explicitly list those in exposed props either, right? So we started making more and more exceptions sort of at the request of people who were implementing JS-implemented DOM APIs to make this stuff nicer and nicer. And we made it too nice, and we got security bugs. And so then we started having this like back and forth play between security and usability of these things. And the resulting discussion between me and Blake and Luke and some other people was just that really these things aren't the right way to do it. These aren't a good way to expose APIs to content. Because really, there are these objects that are privileged and the content shouldn't be touching, right? We don't want to pretend that they're some sort of nice object, but also implement a very strong security boundary. So the long story short there is that those things are now deprecated, and we have two stories going forward. And if there's any extension or any developers in the audience who are interested in this, I really want to make sure that these two things solve their use cases. So the first thing is that if you are implementing some sort of DOM API, something you're expecting to be exposing to the web, and you're implementing that in JavaScript, we now have an ability to do JavaScript implemented WebIDL bindings, right? So you write a piece of WebIDL, and then you implement that WebIDL in JavaScript, and our bindings layer will expose that securely. And the reason it's secure is because we have a very strong C++ layer in between that prevents you from having these sort of haphazard references between compartments. So this works if you're baking something directly into the platform and you're landing something in Mozilla Central. But it doesn't work if, let's say, you're in an add-on and the add-on wants to expose some sort of API to content. So I worked with Gabor and Irakli and a couple other people, and we came up with a couple primitives that allow the Jetpack SDK to sort of safely expose these things. And the basic idea is that you sort of export these functions to content, and these are sort of special functions that content can call, but everything that passes back and forth between the boundary is either structured cloned or X-rayed, right? So structured clone is sort of a better version of JSONing something and then un-JSONing it. And so the idea is that you never actually get these direct references to JavaScript objects on the other side, unless those JavaScript objects are DOM objects, in which case you have X-ray wrappers and you don't have to worry about that whole cow situation. So Gabor can tell you more about sort of exactly what their plans are to add some sugar to this in the Jetpack SDK. But my hope is that this sort of division of if you're in the tree, use WebIDL bindings, if you're not in the tree, use the add-on SDK, should hopefully solve everybody's use cases to the point where we can eventually get rid of exposed props. Because right now it's a little bit of a security hazard.
Is there a plan to get rid of them? There's like 100 in the tree or so.
Yeah, I mean the biggest problem right now is that a lot of our JS implemented web APIs are not using WebIDL bindings.
Yeah.
They're using the old way, which was using cows. And that needs to change, right? And so the people who've implemented these APIs, like I just spoke with Fabrice, and he's has these bugs, and he's planning on eventually moving these APIs over to WebIDL bindings. At which point, once we get these all fixed in our tree, then we can start looking at add-ons MXR and seeing how big of a problem it is.
It doesn't look too bad.
It's
A lot of bootstrap stuff.
Okay. So last topic, I know people are getting a little fidgety and maybe have some more questions. But this is kind of the sexiest topic of them all, right? Brain transplants and wrapper
It
recomputation.
probably makes you sound really cool at parties.
Yeah, brain transplants, right? Like Johnny had these T-shirts that said like I survived brain transplants, and then he made one for his daughter or something. Said my daddy survived brain transplants. Anyway, so this whole compartment model is really good when you have this idea that an object has a very fixed origin, and that origin doesn't change, right? And because the object lives somewhere in a compartment, and that compartment has an origin. And really there's only two ways in which that origin could change. One of them would be if we actually went to the compartment and we changed the origin of the compartment. The other would be if we somehow had this crazy way to move an object from one compartment with one origin to another compartment with a different origin. And strangely enough, we actually do both of them in the platform today. So the primary and initial motivation for this was during the Firefox 4 release, when everything was moving towards compartments. There was this realization that we were totally and utterly screwed about the window object. Because the window object, as you know, is kind of special, right? Because when you navigate a page, in particular when you have a reference to the window object of an iframe, and that iframe navigates, the window object kind of always refers to the active window. And it always has the security characteristics of the active window, which essentially means that the window object needs to live in whatever the compartment of the active, global is, right? So we call it, the window object is really the window proxy in spec terminology. So long story short, Peter and Blake and Johnny and Andreas spent like a number of months just crazily hacking away, and they did this thing that's like, kind of frightening when you look at the implementation, but it really actually like pulls something from one region of memory and moves it over to another region of memory, and just like sweeps over everything and updates all of the references to point to anything. So it's scary, but it works. And that machinery of updating all these references turns out to be useful in another very interesting way as well. So obviously, Anna is very interested in document.domain. So document.domain is perhaps one of the most perverse things in the web platform that unfortunately is in the spec because the web depends on it. But the idea is that at will, a web page can mutate its origin. It can say, I don't want to be this origin anymore, I want to be that origin. And we have a particular list of types of mutations that it can do, and basically it can just chop off like parts of its subdomain. So fupi.example.com can set its document.domain to example.com. And then its security privileges change a little bit. They don't change entirely to example.com. They change to example.com with other people who have explicitly set document.domain so that you can't like arbitrarily XSS your subdomains. But nevertheless, the security characteristics change. And this is a very interesting situation because what we do in this situation is when we do that, it's very simple. We just update the principal on, or the origin on compartment, and then we use the brain transplant machinery to just recompute all of the cross-compartment wrappers going in and out of this compartment. And then bam, we just throw the old ones away, we regenerate all the ones we need, and then these new ones that we regenerate all have the appropriate security characteristics baked into them. So we can actually revoke references to things that you are allowed to see before, but not allowed to see anymore. WebKit, of course, can't do this at all. And so what they do is something that's not very secure, which is just that, you know, they let you have the references, right? Like, literally, Adam's answer is that document.domain is evil and should burn in fire. And he doesn't really have a huge interest in making it secure. But what that basically means is that anybody who's using document.domain, if I'm using document.domain, if before setting document.domain, I grab a reference to some other same origin iframe, then I can set document.domain to something else, and I can hand that reference off to somebody else. And as long as that reference never gets back into that tiny little play place of like those 3 objects where they do security checks, every single other cross-origin caller can just waltz around in this DOM of this poor unexpecting frame, right? So basically, you can be totally XSS'd by anybody same origin who, you know, decides to set document.domain and leak your references to other origins. So that doesn't happen in Gecko. And, you know, in general, this is sort of another example of the way that our compartment boundary gives us this very flexible things, this very flexible mechanism to do all sorts of interesting security stuff, right? Because we have this boundary, because there's never these direct references, we can always enforce the security policy that we want, and that can mutate a little bit, and it can be customized, and it only exists at the wrapper boundary, and that's pretty awesome. So, Henry.
What does Trident do in that case?
You know, I don't know. They don't participate in the WebWG, so I haven't talked to them. But I should ask. Does anybody know? Probably not. Yeah, so anyway, that is the content part of the talk. And at this point, like, I'm here, Gabor's here, Blake and Peter are here, and totally happy to answer any questions. You can ask questions now, or you can come up and ask us afterwards. And hopefully that was helpful. So any big group questions people want to ask? Yeah.
I want to expose an object to a web page.
Mm-hmm.
But I want also to that web page to be able to use expanders on that object.
Uh-huh. Wait, who uses expanders?
The web page.
The web page wants
to set expanders on that object.
Mm-hmm.
I use export to property, but it's not that convenient to do that.
Yeah, you don't want to use. You definitely don't want to use expose props for that. Are you shipping something in the tree, or is it an add-on? Sorry, are you shipping this in Mozilla Central, or is this an add-on?
No, that's only for an add-on.
Okay, so if it's for an add-on, then unfortunately you can't use the WebIDL JS implemented stuff. But hopefully, with this strategy, right, with the Jetpack strategy, we effectively use structured cloning to create a new object in the target compartment. And that object has these sort of methods and functions hanging out of it, but they're not cross-compartment wrappers. They're just objects and functions that know how to go underneath the whole compartment boundary and invoke the appropriate code on the other side, while cloning everything appropriately. So the point is that you can have these expandos, because the object where these methods live.
If you guys are going to talk back here, please leave. We love you, but there's a conversation that some of us can't hear. Okay?
Thanks, Dad. So basically the object upon which the API is exposed is going to be a bona fide content object, and then content can just define whatever it wants on it. So hopefully the Jetpack solution should solve that.
So you can ask guys have sea cows. How are those related to cows and the other costs? Not at all, a little bit?
God. We're working on it. So there are a number of interesting questions with respect to cross-process object wrappers, right? So the idea here is that this is a wrapper that wraps you objects from another process. right? And in particular, when you have an X-ray wrapper, there's this question of, like, for example, do you have a CPOW to a Chrome compartment in the content process, which then has an X-ray wrapper to the content thing, or is it somehow like baked in, right? And in particular, if you as the Chrome caller want to place expandos on the content object, then the wrappers need to be combined, because otherwise, like, anyway, the point is that this hasn't been figured out yet, but this is something that needs to be figured out.
Do we know when we'll have it figured out?
I'm waiting for the HNS people to come talk to me. Or I don't know, I have talked to them about this before, but what has been said before was that this is not like currently the biggest problem, and it's something we'll solve later.
Thank you.
I think you just got the question I was gonna ask.
Come on.
So, like, with the profiling stuff you've been working on, I was sort of interested in getting the time we spent, like, while doing execution, sort of classifying by origin, and I wonder if I could sort of piggyback off, like, the enter and exit compartment.
Totally. Yep. You can just profile and ask what current compartment you're in. And okay, so there's this other weird thing which is called a JS context, and I'm hoping it'll be gone by the end of the year. But basically, what you want to do is you just do ns content utils get current JS context, and then you wrap around that a function to JS get context compartment, and then or actually, if you want to just do it by origin, you could just do ns content utils get subject principal, and then that will just do the origin. That is responsible for the currently executing code.
Okay, cool.
Do workers from the same origin get different compartments as opposed to yes?
So workers live on different threads, and all of the wrapping machinery is main thread only. And the idea is that workers just have a different security world where it doesn't matter. So they do have a compartment, but there's none of this kind of wrapper stuff, because there's only ever one compartment involved.
Where can I get more information on the web IDLs?
The WebIDL implemented JS stuff?
Yes.
JS implemented WebIDL. You know Doug?
I can send you information.
I'll-
If you send me an email.
Yeah.
Sure.
Doug T. And yeah, so this is stuff that Andrew McRae wrote, and we're moving everything towards it. There's a lot of examples already in the
Yeah, that's
town content, yeah.
How slow are these wrappers?
That's a good question. They're not JIT fast, but they're reasonably fast, especially the cross-compartment ones, right? Like, when we landed this stuff, we definitely regressed. Like, when I landed compartment for global, originally there was just one compartment for a given origin, and then I changed it around so I actually had one for every global, which is where you get these transparent cross-compartment wrappers going on. When we did that, we regressed, like, there were a couple things that like did cross-compartment typed array access. Like Google has this Google has this thing where Google Web Toolkit or something like compiles C++ and they have a DOS emulator, and that ends up doing some typed array access across the compartment that was really hurting us. So Eric Faust is working on a couple of like the really high impact cases like cross-compartment typed array access that we can do simply, but it's actually pretty hard that we can do simply with the JIT, right? But it's pretty hard to JIT anything else. As long as we're in the interpreter, it's all in the same order of magnitude, but when we hit the JIT, like, we definitely suffer because, in the words of Boris Zabartsky, it doesn't help that whenever our JIT sees a proxy, it runs around clucking with its, like a chicken with its head cut off. Right? So that has been a little bit fixed in that the JIT is a little bit smarter about proxies, but it still doesn't know really much what to do about wrappers.
Are we compiling these with JIT, or are we just sort of baking the checks, or are we somehow wrapping them?
We're not currently doing anything about cross-compartment wrappers in the JIT. We are doing stuff about proxies, right? So like we can JIT like proxy info or something. I don't know much about the details. You should ask Faust about that.
Yeah, I mean, he's working on more general cross-compartment wrapper stuff, but it's the sort of thing that's like multiple months of work, and it's kind of crazy scary, and like the number of like things and bits of knowledge you're encoding is kind of crazy. Like,
you don't want to rewrite XP Connect in the JIT, right? Like all
yeah.
the security policy that we have is pretty.
Like you can put in little inline caches that say like if this object is always a cross-compartment thing, then we can try and speed it up. But it's still going to be a little bit slower than like a direct same compartment access.
What different apps are there that end up hitting the cross-compartment case?
Often, like for example, even Gmail uses a number of iframes. It kind of uses it as a method to sandbox like code and get different scopes and that kind of thing, sort of as a replacement for modules or whatever. So there are cases where websites do use multiple same origin iframes, and those will hit the cross-compartment case. Hopefully they don't actually do tight loops that cross the cross-compartment boundary, right? They're just going to cross it once, they do tight loops within it, at which point it doesn't really matter.
I know that there's some way to emulate some of the Clash stuff, which requires you to have a separate global, very basically. You would basically make a new global and pull constructors out of that. And this is, of course, hitting all the cross-compartment boundary stuff.
Right, so for performance critical stuff like that, we do have maybe some Hail Mary JIT solutions, but it's probably better to just try and not make performance critical things like cross compartments in a thing.
So, are cross-compartment wrappers just another species of proxy? Like, is
Yes, they are a family of proxies.
Right.
So they're implemented as C++ proxies. And then we have this whole template hierarchy of proxy handlers, and some of them eventually, at some branch you end up actually getting the direct proxy, the scripted direct proxies that we expose to the web. But we have, all sorts of other scripted indirect proxies and dead object proxies and wrappers and DOM proxies, and proxies are just sort of a general mechanism that we use to have JS objects with custom behavior. Henry?
So how do you GC across the cross-compartment wrappers?
You mean, okay, well, so cross-compartment wrappers, they will of course hold their target alive. But are you talking about a compartmental GC in particular?
So, I mean, just in general, what are the implications for GC, since the compartments were supposed to make it so that you can GC the compartment, and
Right.
you have indirectly these references, perhaps with a cycle in between, like this pointing with a wrapper to that compartment, then it pointing with another wrapper back. What happens?
Yeah, so basically, I think I even maybe forgot to mention this, the reason these wrappers make the GC story work is that the wrappers are explicitly enumerated in a map, and the GC knows about them. So when we're doing a compartmental GC, like when we're only GCing one compartment, then what we do is we just look through the system at all of the incoming cross-compartment wrappers, and we just mark all those as roots, right? We just say, these are the things that, given our limited worldview right now, that we cannot prove are dead, so we're just going to say that they're alive for now. And this was sort of the problem why, compartmental GCs never end up really collecting as much garbage as we wanted, because there were a lot of cross-compartment wrappers that ended up holding things alive that could have otherwise been marked dead. So we can get some stuff, but often we need to do a full GC anyway. And in terms of lifetime management, a cross-compartment wrapper to an object will hold the target alive.
So at the very beginning of your talk, when you talked about Firefox 4, and you said that the performance gain of all of this didn't make as much sense as you would have hoped, or you didn't.
Right. This is
Why was that?
what Bill and Smog have told me. Smog, you can
Yeah, about
elaborate.
GC's behavior. Yeah, well, because we cannot do just one compartment GCs too often. We have so many references. We need to GC most of the compartments, but that's why incremental GC helped quite a bit.
If you look for benchmarks, it's more or less for some spider, but you don't have these process right.
Okay.
Yeah, in that one, yeah.
Okay. Thank you.
So you said at the very beginning that the memory addresses encode the compartment, and you just mask off part of the address to get the compartment, right?
Well, yeah, to get the arena. And
Yeah, the arena.
Yeah.
So, where do you split that in a 32-bit machine?
Oh, I don't know.
I'm just thinking. I mean, is there some coalescence? Is there some coalescence mechanism if you start getting outside that? I mean, I'm just thinking you either have a lot of them, or you can have
It's not deterministic.
Well, I mean, so you have some arena of some fixed size, right?
Yes.
And maybe that arena is going to be 1K or 2K. I don't know what our arena sizes
Right.
are. But then you can fit some number of objects in there, and if you need more objects for a given compartment, you just make another arena.
Right. Okay. Yeah. So you can have multiple arenas for the same compartment.
Yes.
Okay. That's what I was getting at.
Yeah. Is that a hand or no?
So on the getting back to the thing of making them fast, so with the ICs, trying to make them handle cross-compartment wrappers, I guess the main problem is you can't really hold any actual pointers to, you can't embed pointers to the other compartment in, say, a stub IC stub you're generating, for example, for a sheet check or something.
Right. So you can do basically this is why typed arrays work well, because the data that comes across is very simple. where the big problem with doing any sort of IC stuff for like, for doing any sort of JIT code for cross-compartment stuff is that you still need to wrap, right? And wrapping is a complicated process that is hard to JIT effectively. Or maybe that wasn't your question, sorry.
No, so are we thinking about making them faster than that, or are we just sort of giving up on that, or like, you know?
I don't know. I mean, eFaust was looking at it, and then we determined there was some low-hanging fruit, and I kind of reordered the ordering of wrap things and made things like, you know, 40% faster or something, and then we were all happy about that, and then stopped thinking about it. I don't know. Do you know? But do you think eFaust is probably not going to do it, or do you know?
It'll just take a while.
But is it going to happen?
I don't know. He's got a certain amount of time and lots of demands, so.
Yeah. Would it be possible to share shape trees?
Between compartments?
Yeah.
The shape is currently how we determine where the object's compartment is. So,
Okay.
Probably not.
That's an
yeah, it seems unlikely.
What happens if you take an object and pass it to a number of compartments and then back to the original one? Can you access things on there, or does it sort of unwrap all of the wrappers?
Right. So that's a great question. Every time an object moves from one compartment to another, the first thing we do in the operation of creating a wrapper for it is to strip off any pre-existing wrappers. So we never have this sort of situation where you kind of have a history of like wrappers around wrappers around wrappers, because every time we move it to a new compartment, we just throw all the old ones away and compute the precise wrapper we need for the security characteristics and relationship between the new place where the wrapper is going to be and the place where the object is.
What can I learn more about the mechanism that you were talking about for add-ons to expose functions?
Talk to Gabor. This guy. Raise your hand. Stand up.
And I'm actually looking for add-on developers who has this problem because, the SDK part of the API is not there yet. So to design that and get it right, it would be great to have some add-ons.
Is it documented anywhere?
Right. So I don't think it is. We have the platform piece of it in, and then the SDK part of it has yet to be designed, I think.
What about the non-SDK part? We have a lot of add-ons not on the SDK yet. Like a couple of, I just looked into add-ons MXR, and there are like at least, well, it showed me the first 1,000 hits, and most of it was add-on SDK. But there are a couple of add-ons like Grease Monkey or Firebug, who actually use exposed props as well.
Well, at some point, those are going to have to change.
Yeah, they should be able just to load in a module that has all these utility functions that is building on top of this.
Right, yeah. They're not going to have to move to the
SDK. Would
SDK.
be playing JavaScript code module, not an SDK module, because then you would need to use an SDK loader, and that would be complicated.
Yeah, so we don't want to force all the old add-on developers to switch to Jetpack necessarily. That's not the goal. So, yeah.
Yeah, that's a very good point. Yeah, we should make sure to make that available. Like, it's going to have to change in terms of their usage of exposed props, but we should obviously not force the entire SDK on them. I mean, they can use the primitives, right? These primitives are exposed to anybody who creates a sandbox, right? You have these like import helpers that allow you to define functions in content.
Well, it's not just functions; it's properties as well.
Well, no, so you can.
A lot of stuff I saw on MXR is like I have this object, and it has some functions and some properties, and I want to make most of the time I want these properties made to be functions or plain values. I want to expose these as readable.
Right. So what we do then is that we have the two primitives are one that's called eval in window. It's kind of like eval in sandbox, but it operates on a window. And the other one is an export function, which basically creates one of these functions that is safely callable by content. So basically what you would do is you would eval in window to kind of set up the object the way you would want, and then you would export function to create the various functions that you wanted to stick on.
Okay, so you work around it.
Yeah. Well, I mean, the idea was these are primitives, right? They're not supposed to be a really fancy, snazzy API.
Of course.
Yeah. There's another question back there. Okay, so the properties are just leaked? Yeah, okay. That's what I would figure. Anything else? Cool, well, I'll sit here and feel free to come talk to me.